about work today. And work, most important thing that we need to know is work and energy are synonymous. They're the same thing. Work means energy. And in fact, work is the amount of energy that's transformed from one form to another. Like when you drop something, gravitational potential energy is transformed into kinetic energy by a force that acts over a distance. And so the force that's acting if you drop something is the force of gravity, and that force of gravity is doing work to increase the kinetic energy of an object at the same time as the gravitational potential energy decreases. And so work is when energy is transformed from one form to another. We can calculate it. Work is force dot distance. So W is work, F is force, D is distance through which the force acts. The dot means times, but because these things are vectors, the distance is a vector and the force is a vector, it carries a little bit more information. It tells us that the force and the distance have to be in the same direction. That's going to have implications for us when we come to solve problems. Let's have a look at what that's going to look like. This is the sort of problem we're going to have to solve. We've got a force, 200 newtons, but it's not acting in the same direction as our distance. This person's dragging a crate along the ground. They're pulling it with a force of 200 newtons, and they're going to pull it for a distance of 5 metres. We've got to work out how much energy they're going to need to do that work. But the trick is that we can't just go 5 times 200 to get 1,000. That's not the work done. What we're interested in is the force that acts in the same direction as the distance. So we're going to need to draw a triangle and calculate off that component of the force. This is the kind of triangle we draw. We've got the force that they're tugging on the rope with, 200 newtons. But we know there's an angle here of 30 degrees. So if we want to work out the force, the component of the force that's in the same direction as the distance, it's the adjacent side of the triangle. So we're going to cos it. 200 cos 30 is 173 newtons. So although they're pulling with 200 newtons, only 173 of those newtons are in the same direction as the distance. So now that we know the force that's in the same direction as the distance, now we can calculate the work done. 866 joules. That the other component of the force, that's going to be acting against the weight force. So we're going to have a weight force on our crate that's pulling it down, and that upwards component is just going to reduce a little bit the normal force that acts on the crate. It's going to make it slide, in fact, more easily because there's going to be less of that weight supported by the ground and more of it supported by the rope, supported by the ground through the feet of the person.